Hi, welcome to the fourth video in the Writing and Compiler series. In video one, we designed a programming language. In video two, we set up a project. In video three, we wrote a parser. Parser that we did in video three produced a concrete syntax tree. It's all done within the Ohm language library. But what we need to do now is convert that into an abstract syntax tree for semantic analysis and then finally optimization and code generation. Okay, so what do we mean by the program representation or abstract syntax tree? Okay, so for abstract syntax tree, by an abstract syntax tree, we mean the representation of a program in terms of objects that we can use for semantic analysis. So given this program in Pidgin, what actually is this program? What is its representation, or what does this program represent? Well, it's a program with two statements. The first of which is a variable declaration. This variable declaration is defining a particular variable and initializing it with a value. The variable that it is declaring is a variable named x, and it's being initialized with the result of evaluating a exponentiation expression, which is a kind of a binary expression whose operator is the exponentiation operator, and whose left operand is the number 9, and whose right operand is the number 3. Okay. There is a second statement here. The second statement is a while statement. And while statements have a test and a body. Test and a body. The body, we'll do that first, it's a little bit easier, is a print statement whose argument, the thing it is that we're printing, is the string hello. The test we see is a binary expression whose operator looks like less than, whose left operand is the variable x. Just catch it here in the variable x, and whose right operand is the variable y, which is actually not declared. So if we were doing semantic analysis on this, we would have to issue an error saying that y was not declared. So for right now, we'll deal with errors later. Let's just pretend this was the number 8. And I'll add the 8 right there. Okay. And that's basically it for this one. Let's take a look at one other one, which might be helpful to look at. Let's look at function declaration. So suppose we had a function, we'll just call it add3. It'll take in an integer, it'll return an integer, and we will definitely return x plus 3. So nothing too fancy there. This is a program with one statement. Probably program, I think I called it. One statement in its list of statements, and that is going to be a function declaration. What do function declarations do? Well, they declare functions by giving them a body. The body in this case is probably a little bit easier to do first. The body is a return statement whose expression being returned in this case is simply a plus expression. So we have a binary expression whose operator is plus, whose left operand is the variable x. We'll have to pick that up later. And whose right operand is the number 3. We'll have to show how to get x. Well, let's get x because it's from this function. Okay, so the function that's being declared has a name, The name looks like add3 is the name. It has parameters. And it has a return type. Now, sorry, return type. What is the return type? Int. Well, what's that? Okay, well, that's going to be something that's just built in. We need to have a built-in representation of the type, the built-in type whose, I don't know, right now we'll just say its description is int. We'll deal with where those come from. We'll have to deal with where that comes from pretty soon. Okay, but yeah, that's going to be the return type. And for the parameters, well, there's just going to be one parameter. Parameters are actually just variables. And in this case, the variable has the name x. But unlike what we saw before, it's pretty clear that variables actually have a type. In this case, the type of this variable right here is going to be int. So the return type of the function is int, the type of this variable is int. And while we're at it, let's show that this x plus 3 is actually going to be have its left operand just be this variable here. And then so we can use things like this to do our type checking and declared variable checking, parameter uniqueness checks, and all that other kind of stuff we have to do when we have semantic analysis. You know, in doing these checks, it's kind of clear now that we see that variables have type, but you know, not only do variables have type, but these expressions have a type too, right? If we're adding x plus 3, well, the type of this thing here is also an integer. And what we've done before, where we created this program, this is the first one that we looked at over here. It's clear that this variable x right here, we were able to infer its type over here as being also the type int. And by the way, how do we know that this was the type whose description was int? Well, we actually got that by inferring it from this binary expression. All expressions really should have a type. So if you see a power and then you see two integers here, you know that this is going to be a type. And if you know the initializer, right here, the initializer is going to have an int, then the variable that you declare is going to have a type of int. And then, you know, hello will be a string. Oh, I see another type over here. If all of our expressions are supposed to have types, what's the type of x less than 8? Okay, well, x is an int, 8 we know is an int. That type is going to be another built-in type. We'll have a built-in type here for Booleans. So type description bool. We'll probably call it Boolean when I get there. But that's the deal. Okay, so our job now is to go back to our compiler and actually build classes that represent all of these things. Okay, so here we are back in VS Code. We're going to create all the classes for those nodes in our program representation in a file which we'll call core.js. So we'll touch src core.js and we'll start creating them here. Let's give ourselves a little bit more space in VS Code by splitting, closing this thing. And so what we want to do is we want to see the syntax here, and we'll create everything over here. So we see the first thing we see is a program. So let's go with class program. And programs are going to have statements inside as the property. So in our constructor, we'll put in statements, and then we'll just assign it in the constructor. So object.assign this and statements like so. So that's our program. Then we have very similar kind of statements. The first one, I see a print statement, constructor. What do we have? It's just the argument that's being printed. So argument, we should probably spell it out. Argument and object.assign. I really should have Copilot here. Copilot would help me build all these things just fine. Argument. class assignment statement is next. So assign statement. Now this constructor for the assignment statement, this needs a variable and an expression. So variable and the expression. You know what? We assign a source to a target. We should be a little bit better because who knows if it's just variable. Let's do target and source. And then object assign target source. Oops, did that completely wrong. This target source. Save that. Some more variable declaration. It gets interesting over here, the variable declaration, because the variable declaration, even though it has an ID and an expression over here, as we showed earlier, what the variable declaration is really doing is it actually is binding a variable to its initializer. So I think it's better to say constructor, we have a variable, and then we have an initializer here. Okay. Object, oh, thank you for correcting my spelling. Assign this variable initializer. Okay, and then the variable itself, that's going to have a name. And there was a type in there too. It's going to have a name and a type. Now, in a variable declaration, you don't see the type, but you will see it in a parameter. So there we go. Object, assign, name type. Okay. While statements, I believe, are next that have a test and a body. But I'm going to type them all in. I'm just going to bring them all in, and then we'll just talk about it. Okay, I've got them all typed in here. So again, a program is a list of statements. A print statement prints an argument. An assignment statement assigns a source to a target. A variable declaration associates a variable with an expression, which is going to be the value of the initializer expression. The variable itself is where the name of the type are stored. So when we declare a variable, we want to point to the variable with the name of the type and have the initializer out here. While statements have a test and a body. So like while some test do some body. Function declarations associate a function with the body. The function itself is where we store the names, the parameters, and the return types. Oh, what are the parameters? Oh, each parameter is a variable, so we don't need a special class for a parameter. Return statements, every return statement returns an expression. A block is a list of statements. And then under type, you see you have two kinds of types over here on the left. We have a basic type, which is just a name, but we have an array type, which is a type of some other type, right? So an integer array, the type int array has a base type of int. For expressions, we have binary expressions. They have a left and a right operand. And we have array expressions. Those are these things right here, just a list of expressions. So we just store their elements. And for subscripted expressions, we have an array with a subscript. So some array over here, and then whatever the subscript is. And finally, we have calls, where we actually are calling in hopefully an existing function and passing in some arguments. At this point right here, we can see that something seems to be missing. We have a way to represent binary expressions, that is, expressions that have a left and a right, but we really don't have negation here at all, right? So, I mean, there's no way to say like, -5 or something. So it'd be a good thing if we had a unary expression. So let's put in a unary expression here. Can't hurt, and it will just have a single operand. And then we'll try to work that back into our grammar. But now, anyway, we've just written a bunch of core classes which are going to allow us to represent functions. We haven't written any tests for it. There's really nothing to test here yet. The tests are going to come in when we start building up the program representation, but it's good practice to make sure that adding that code did not break anything. So let's do npm test again, just to make sure that everything is still passing. And it does. And you can see that our test never actually touched core.js. So it still looks like we have 100% test coverage because, we never really used that module. But while we're here, speaking of unary expressions, that did look like it was a miss in our grammar. So since this is a relatively short video, let's try and get it in here. I would like to also bring up, in addition to the test, I think we should bring up our parser, parser.test.js. Let's bring up the parser test. Let's make sure that we're able to handle negation as one of the tests. So let's drop in a new test right here and say negation. And let's try and make sure that we can print something like, -2. And if I hate when that happens. We got to put a comma in there, otherwise VS Code will do crazy things. Okay, that test, I believe, is going to fail because we don't have a way to put a negation in there. And sure enough, it does fail because it doesn't allow expressions to start with that. So let's get into the grammar so that we can have negatives in there. Where do we put negation? Where in the hierarchy does it go? Well, there's a fun fact which I think is useful to know, and that is, if you've ever seen the language Python and you try to do -2 to the power 2, well, in Python, this evaluates to -4 because in Python, exponentiation has higher precedence than negation. And so despite the fact we put spaces over here, this will compute to 4 first, -2 to the power 2 will be 4, and then we'll negate it to be 4. JavaScript has an interesting approach which actually makes this illegal. And the way they do that is they said they don't want you to be able to have negation mixed with exponentiation in just that way. And the way you do that is kind of interesting. You put your negation in the factor right here. So you say negative primary, and this is just going to be a negation. And with that, you allow the negation to come first. Let's make sure it does by testing. So I can have the negative there. So I can just say print -2 like I did over here. I do want to say that negation can come first, or no, negation cannot come first. Negation can come second. So we want to allow this print to the -2 power. We can have it, again, don't forget your comma. We want this here, but we should say something over here about negation cannot come first. We want to make sure that our parser is actually rejecting this. Okay, we don't want this to be allowed. And where would that error be? I don't know, 1, 2, 3, 4, 5, 6, 7, 8, about column 10 maybe? Let's see if we get an error on column 10. Just saying. Just trying it out, see what happens. npm test. See if we got it working. I don't have it quite working. It was a column 11, but it still recognizes that you can't have the exponentiation after the negation. That's not something that should work. And let's see if our tests pass. And they do. All 45 tests pass, so we're in good shape. So we've cleaned up our grammar a little bit, but most importantly, we have added all of these classes here. So next up for us is to make sure, or I'm sorry, not make sure, but we're actually going to take the result of Ohm's grammar match, a concrete syntax tree. We're going to navigate that concrete syntax tree, and we're going to produce these graph-based program representations that we drew pictures of at the beginning of this video. Okay, thanks for watching.